All right, guys, welcome to the second video for the 9.7 notes. And before you stop the first video, I hope you wrote down these first 6 problems, and I also hope that you have attempted them first. If you have not attempted these problems yet, please pause now and do so. I think it's important to see if you are getting them right without me. So if you have attempted them, here were my answers that I got for the first couple. My answers for number 1, because I was given the shortest side, is I multiplied the shortest side by root 3 to get the longer leg, and then the shorter side by 2 to get 14. If you got that, great job. Number 2, I was given a 45, 45, 90 triangle, which meant that my legs were the same, so this should have been 6, and this side would be root 2 larger than the legs, so 6 root 2. Again, if you got that one, good job. Pretty much if you got a lot of these, great job. Number 3, I was given a 30, 60, 90 triangle. This time I was given the longer leg across from the 60. So when I looked at my triangle, I realized that to get from my longer leg to my shorter, I had to take the number that I was given and divide by root 3. And when I did so, I got the shortest leg to be 4, which meant that my hypotenuse was double the shortest leg, so 8. Number 4, I was given a 45, 45, 90 triangle and was given the hypotenuse of 11 root 2. Now, if I look at my 45, 45, 90, I know that the largest side is your leg times root 2. So if I want to go from here to here, I have to divide by root 2. And so when I took 11 root 2 and divided it by root 2, I get that both of my legs were 11. Number 5 was a little tricky. I was given another 45, 45, 90, but this time I was not given the hypotenuse with something with root 2. I was given the hypotenuse of 2 root 5. But I did the same thing. I took to the hypotenuse 2 root 5, and I divided it by root 2 because I knew I had to get from my hypotenuse to my leg. And when I did so, and I rationalized in blue, I got the numerator to be 2 root 10, and the denominator to be root 4 technically, which is just 2. The 2's crossed out, and I was left with both of my legs being root 10. Number 6, I was back to the 30, 60, 90 triangle. This time I was given my hypotenuse of 20. And the best way, or the best next thing to find, would be your shortest leg here. And so I took my hypotenuse and divided it by 2 to get 10. And then once I got 10, I knew that my longer leg was root 3 larger. So this was 10 root 3. Because for the 30, 60, 90 especially, it all depends on what you're given. But your goal on every single 30, 60, 90 triangle is to find your shortest side first. Because once you know that, you can find everything else. These next 2 problems, if you did not get a chance to copy them down and try them on your own first, please do so now. If you have attempted them, I'm going to show you the answers that I got while you were trying them on your own. My answers for number 7 were 21 and 14 root 3. And 14 times root 3, by the way, guys, is 24.25, so this is definitely bigger than this. What I did was I noticed that I was given the smallest side of 7 root 3. So to get to the longer leg, I took 7 root 3 and multiplied that by root 3, which is really 7 times 3 or 21. And then because, again, I had the shorter leg, I took the 7 root 3 and doubled it to get my hypotenuse of 14 root 3. Number 8, I was given my longer leg of 12. And I know that my longer leg is really x root 3, and I wanted to get to just x. So I had to rationalize again here, because I had to take my 12 and I had to divide by root 3 to get from here to here. And when I rationalized, multiplied top and bottom by root 3, I got 12 root 3 on the top, and then root 9 or 3 in the denominator. I then reduced 12 divided by 3 to give me 4. So this smallest side here ended up being 4 root 3. And once I knew the short side was 4 root 3, I knew the hypotenuse was double of 8 root 3. As a memory trick, by the way, something that I've used over the years to help remember which one is the root 3 and which one's the root 2, this 45, 45, 90 triangle has 2 congruent sides, which is why this is x root 2. And in the 30, 60, 90 triangle, we have an angle that has a 3 in it, 30. So that's why I always think of it as x root 3. They're just little memory tricks to help. So because 2 congruent legs, we have root 2. Because I have a 30-degree angle, that's why it's root 3. Thought that might help some of you. Again, feel free to pause and re-listen to how I explained any of these. You can go back and try them again if you'd like to. I'm just trying to give you options and feedback here. There are two more examples that I want to do. And the first one says, given that ABCD is a square, we want to find the perimeter. Well, if I know the shape is a square, I know that all my angles across the board have to be 90 degrees. What I know even more from first semester is that my diagonal, or both my diagonals technically, bisect the angles, which means that this triangle here and this triangle technically end up being a 45, 45, 90 triangle because these two angles are 90, and if they're bisected, it has to be split in half. So what I really have here is a 45, 45, 90 triangle where I give the hypotenuse of 6. So if I would like to get from my hypotenuse to my leg, if I drew my 45, 45, 90 triangle here, I have x root 2. So I'm given the 6 is x root 2, and so I want to get to x. So I have to take 6 and I have to divide it by root 2 to make it smaller, and then I have to rationalize to get my answer a little nicer. So I'd have 6 root 2 in the numerator. My denominator would be just the number 2, and if I reduce this, each side would be 3 root 2. 3 root 2, and because this is a square, I know that these two sides also have to be 3 root 2. And so if I'm looking for the perimeter, I'm really taking 3 root 2 and multiplying it by 4, or adding 3 root 2 4 times. And if I do that, remember that when you are adding radicals, we cannot change the radicand. We just say there are 4 sets of 3 root 2, so that would be 12 root 2 units would be my perimeter. Okay, my last example also relates to things we know from first semester. Given that ABC is an equilateral triangle, we would like to find x and y. As soon as I see that word equilateral, it also means automatically that it is equiangular. And as you may recall from first semester and into this one, we also called that a regular shape. And so that means if it's equilateral, all sides are equal and all angles. So I know if I have a 180 degree shape, each angle would have to be 60. But if I drop an altitude, which is a good idea most of the time, what I can do is prove that these two triangles are equal, because I would have angle, angle, reflexive side, angle, angle, reflexive side. If these two triangles are equal, it means that these two angles are equal also, because of corresponding parts. So I would know that both of these would have to be 30 degrees. So what I again really have here is a 30, 60, 90 triangle, which makes sense with this unit. So if I draw one of them separately, both of them would be equivalent. I'd have 12 here. Here's my 60 degree angle. Here's my 30 degree angle, and there's my 90. And my goal is to find x and y. This entire side is x, which means that this is only half of it here. And I want to find y as well. So let's use our triangle and see if we can use our knowledge to help us find what we know. This 30, 60, 90, I'm given the 12, which is the longer leg. So if I want to get to my short leg here, I have to take my 12 and I have to divide it by root 3. And if I rationalize that, multiply top and bottom by root 3 over root 3, I'll put that in purple too, so you can see that was not the original problem. I would get 12 root 3 in the top, or in the numerator, and the denominator I get root 9, which is really 3. If I reduce these, I would get that this side here is really 4 root 3. So in my picture, this is 4 root 3. This triangle is the same, so this also would be 4 root 3. If I look back at my 30, 60, 90 triangle here, my hypotenuse here has to be double my shortest side. So my hypotenuse has to be 8 root 3, which also makes sense with my picture. 4 root 3 and 4 root 3. My x value is 8 root 3 because that's total. And because of my triangle also, this side would also be y, all of them of which would be 8 root 3, which makes sense with my triangle and also makes sense because the triangle given was equilateral. So all sides are 8 root 3. So what I would suggest again is if there's any examples you want to go back and try again, please do. These special right triangles are going to be used the rest of the semester. Not kidding when I say that. They come up so often. Also, they do come up in pre-calculus. I teach that and I know it does come back. So if you are confused on anything, please come in with questions. Let me know if I can re-explain anything in class. All right, guys, thanks for your attention, and I'll see you the next class.